In 10.2, we're going to study hyperbolas. 10.3 is also in the course outline, but it's parabolas, and you've studied parabolas enough. I'm going to talk about them a little bit in this video. That's why I included it in the header. But we're not going to focus too much on the parabolas. You've done that before. Okay, standard form of a hyperbola. It looks just like an ellipse except for a minus sign. So you already know how to find the center, how to get this into standard form. It's just that now one of these things is negative. Whichever the x or the y part is positive tells you the orientation of your hyperbola. If the x is the positive one, you're horizontal, and your major axis is going to run horizontally. If the y is the positive one, then your major axis is going to run vertical. Now, in this case, major and minor doesn't mean longest and shortest. It means, is it horizontal or is it vertical? And remember, it's based on whether the y part is positive or the x part is positive. Okay, let's graph one. This is a little bit more complicated, but it's still not bad. First, you find your center. In this particular problem, it's 0, 0. Then you find your radii. You're going to go out 3 in the x direction and 2 in the y direction. So I've plotted my center. Now I'm going to go to the right 3 units. Because this is a horizontal one, right? The x part is the positive, so it's horizontal. I'm not going to put points in the y direction. My vertices are horizontal because the x is positive, okay? So over 3, backwards 3. Now, watch what I do here. I'm going to go up 2 units. In the y, I made a mistake. Look at that. Hoo-ha. This is 2. You caught me. I knew what I was doing. I just didn't do it. Okay, I'm going to go up 2 units in the y direction, and I'm going to go down 2 units, and I went out 3 units. Boy, is my scale off. Let's fix this. This is not going to work. Let's fix the scale. Okay, there's 2. There's a reason I wanted it to be closer to right. Of course, my left and right, x and y axes are kind of off too. You see how I made a box with my center in the center. And because it was horizontal, I have vertices on the horizontal axis. But I made this box for a reason. And the thing that you use the box for is you're going to connect the corners going through the center and make asymptotes. So connect the corners. It should pass through the center, and I'm making asymptotes. Now your graph has vertices on the major axis, and you're going to approach the asymptotes. So it kind of looks like parabolas approaching the asymptotes. And that's how you draw a hyperbola. Let's do another one. Okay, this one is pretty easy, except I can't spell center. The center, what makes the parentheses equal 0? And remember to put the x first. X is minus 3, y is plus 2. Notice that I have it equal to 1, so it's in standard position. What's the denominator here? And what's the denominator here? Well, they're both 1s. So I'm going to go 1 unit in the x direction, 1 unit in the y direction, but notice that the y term is the positive one, so this is vertical. That means my vertices are going to be on the vertical axis through the center, okay? So my center is at -3, +2. That is not a point that's on my graph. That's why I'm using an open circle. Now I want to go out 1 unit in the x, 1 unit in the y. I know, boring. That gives me this box. And I want to connect the corners through the center. This is not perfect, but this gives me asymptotes. My vertices, we said it's vertical, so the vertices are 1 unit up and 1 unit down along that major axis there. And now I'm going to pass through the vertices and approach these asymptotes. Okay? All right. And these are symmetric, although my graphs don't look like it. That's the process of graphing these things. Okay? So you've had an example of a vertical and a horizontal. Now let's practice completing the square to put it in standard form. Okay, let's practice completing the square to put this thing in standard form. So the first thing you want to do is get your x terms together. Leave yourself a space to work. Now notice that the y squared has a -2 in front of it. That means I have to factor a -2 out of this, which is going to make it -6y. Leave yourself space. Move that constant over to the right-hand side. Okay, half of 2, completing the square now. You take half of the number in front of the x. It's a 1. I'm going to now, by the way, half of -2 is -1, but I'm squaring it. So this is always addition. When we write that in perfect square form, we always use this sign because it was a -1 that got squared. Okay? Now I have a -2, and to complete the square on y, half of 6. Okay, half of -6 is -3, but we're going to square it, so it's always going to be plus. That gives me a y, a minus sign, and a 3, perfect square. Now, on the right-hand side, I added a 1 to the x's, 1 squared, and I added a +3 squared to the y's, but I had a -2 on the outside, multiplying that. So be very careful, okay? Now, on the right-hand side, I have -14 plus 1. Then I have -2 nines is -18. So I have a -32 plus 1 is -31. Whoa, Nelly. Ooh. See, when I started working this problem, it looks like it's going to be horizontal because the x part is positive. But look how I ended up with a minus on this side. That's going to change these signs. Okay? So that once I get this number, I have to make it a 1, positive 1. So I'm going to divide everybody. It's not pretty, but it is what it is. So now the standard form is negative on the x, and positive on the y. So I'm going to write this guy first. I have y minus 3, perfect square, over, watch me, the negatives canceled, 31 is down below, but the 2 from the top flips down to be in the denominator of the bottom, okay? Then I have minus x minus 1 squared over 31 equals 1. So my center is at x is 1, y is 3. Make sure you get that right. X goes first. Out in the horizontal direction, I'm going to go square root of 31. In the vertical direction, because it's the denominator of the y, I'm going to go out the square root of half of 31. I'm just going to write it like this so we can see it. Now, the square root of 15 and a half is almost the square root of 16. So this is almost 4. Square root of 31 is somewhere between the square root of 25 and the square root of 36. It's almost right in the middle. So I'm going to say that this is about 5.5. Okay. So here we go. Let's graph this thing. I'm going to go over 1. Hold on. I'm going to go over 1 and up 3. There's my center. Now my radii, in the x direction, I'm going to go about 5.5. So 1, 2, 3, 4, 5, and a half. I'm going to go backwards 1, 2, 1, 2, 3, 4, 5, and a half. In the y direction, I'm going to go almost 4, 3, 4 would be there. I'm going to go almost that far. I'm making my box. Down, 2, 3, 4. It's a little high there. 1, 2, 3, almost 4. All right, we're going to connect the corners through the center. Connecting. And now my vertices, because the y is positive, my major axis is up and down. My vertices are on the vertical side. Right there and right there. And we're going to pass through the vertices and approach the asymptotes. So this guy is pretty wide. I like to turn my paper. Makes it a little easier to make an arc. Okay, so there you go. That's about as complicated as it gets. Pay very close attention to your signs when you're doing this stuff, okay? And remember, if you get a negative number over here, it's going to flip what you thought, right? Pay attention to whether you're vertical or horizontal based on which one ends up being positive at the end of the problem. All right, a little bit about a parabola. If you have a fixed line and you have a fixed point, I'm going to call this the focus, and this is the directrix. If you have an equation that is the collection of all points that are equally distant from a fixed point, the focus, and a line, the directrix, that point right there would be halfway, right? There's your vertex. If I find all of the points that are equally distant from both the point and the, let's see if I can do one out here. Try to get the length right. It's hard to eyeball it. If those lines are the same length, you do that over and over and over again, and you get all of the points. That's what a parabola is. It's the collection of all points equally distant from a fixed point and a fixed line. So, reflective properties are incredible. You see where that focus is? Anything that's coming in that bounces off the surface is going to get reflected back to the focus. No matter what point you hit, your angle of incidence is going to be equal to your angle of reflection, and everything goes back to that focus point. That's why they call it a focus. But think about the usefulness of that. Have you ever seen a satellite dish, for instance, and there's that little arm with the ball at the end? That little ball is at the focus, and you're getting signals from satellites. No matter where there's the satellite's so far away, it's almost as if the waves coming in from the satellite are coming in parallel to each other. And once they hit a point on the surface, they're going to reflect back off in such a way that they all get focused right there. So that's an example of something coming from outside and being gathered by the focus. What if this was a mirror and this was a light source? So you shine your light from here, it comes out from there, bounces off the mirror, and all of those light rays are going out parallel to each other. The tighter your parabola gets, the more intense the light that's being sent out is going to be. Can you say laser? Something like that, right? Very, very useful shape. Hyperbolas are a lot like parabolas. If you have the two hyperbolas, I'm just going to give an example of something here. Hold the phone. Here's my box. Here's my center. If I have a major axis going through the center, so I have vertical hyperbola, there is a point called a focus that is C units from your, I forgot to do my vertices. There's a vertex right there and a vertex right there, and I'm going to go out C units, and there's my focus, okay? And they'll be equally distant on either end. Okay, and let me draw my hyperbolas here. That does not look symmetric, but use your imagination. All right, so again, you have focus points. This distance is c, just like the other one is. And remember, it's kind of like before, c squared equals a squared plus b squared in this case. So where is your A? A is the, in the book, A is the major. So they would call this A, and they would call that B. And now that I look at it, if this is A and this is B, then A squared plus B squared equals C squared. This would be C, right? Because there's a right triangle right there. So I didn't put my focus points out far enough. I never thought about that before. So let's see, it's the same length as the hypotenuse of that triangle. Very cool. Never thought of this before. That's about right. Cool beans. Okay, so you won't be asked any questions about parabolas, or there may be a circle, but just think of a circle as a perfect ellipse, okay? So from chapter 10, you're going to have ellipses and hyperbolas. All I'm going to ask you to do is graph them. You won't have to find the focus points on either one.